I can't see people's faces, so I apologize for that. If you have questions, please, interject. Um, okay. So if you listen to the headlines these days, uh, it's easy to believe that we're on the brink of two revolutions. The first is that we're on the cusp of creating machines that think, and the second is that we're on the cusp of building computers that harness the strange laws of quantum physics. These two technologies, artificial intelligence and quantum computing, are often described together as the next generation of technological revolutions. They're frequently grouped together in the same news stories. They're often talked about in the same breath, and oftentimes they're framed as equally transformative. But despite this frequent lumping, I really think that they're likely to affect society in very different ways. Quantum will largely transform how we perform certain aspects of science. It has national security implications, and that impact, though, will largely take place in the background and will not be evident in our day-to-day lives. Whereas artificial intelligence, uh, its impact is really going to be at the forefront of our daily experience. It's going to shape how we work, create, and make decisions in our everyday lives. And the remainder of this talk is an attempt to sift through some of those differences and as well as sift through some of the hype that accompanies the common discourse around both of these technologies. So what is this talk about? This talk is going to be focused on the real-world impact of quantum computing and artificial intelligence. I'm going to try and demystify quantum computing in that process as well. And my hope is to contextualize AI a little bit, both about the direction that AI might take society, but also explaining some of the anxiety that exists around artificial intelligence, at least for people of my generation. And this wouldn't be a good talk about emerging technologies if I did not use generative AI to make some of the presentation. So here is a nice image generated by Gemini, which is Google's version of ChatGPT trying to explain a little bit the thesis of this talk, which is that artificial intelligence, its impacts are going to really be front and center in daily work and life, whereas quantum computing is something that has a more limited background impact, but it is nonetheless going to be impactful in the future. So I'm going to start off by talking a little bit more about quantum computing, what it is, what it can do, and what it can't do. And the main takeaway here is that quantum computing is going to be, I think, a really powerful new technology in the future, but its applications are limited. So what is a quantum computer? A quantum computer is a computer, so it's a machine for processing information that harnesses the power of quantum mechanics instead of the classical physics that your laptop or your traditional computer uses. Um, and what that means is that quantum computers are capable of solving special types of problems that our normal computers really cannot solve. And these are problems that sit within narrowly defined yet impactful, really subfields of science. So quantum computers, because they harness or rely on the principles of quantum mechanics, they're able to solve certain problems in material science. They can help us understand the properties of certain really important materials, like certain kinds of fertilizers, which can have a pretty big impacts on certain parts of the economy, like agriculture. Quantum computers, since they fundamentally, again, use quantum mechanics to process information, are really good at performing certain kinds of physics simulations. These are the physics simulations that underpin our understanding of, for example, how nuclear fusion works. So there's the possibility of quantum computers helping with the development of clean fusion energy, for instance. And then moving a little bit outside of the field of the physical sciences, and for some slightly bizarre reasons, quantum computers are also really, really good at cryptography. And because of that, quantum computers are strategically very important at the geopolitical level. Quantum computers have the potential to mm, allow us to decrypt um, certain kinds of encryption that have historically been protecting a lot of sensitive information. And that's a major reason why nation states are, for example, really interested in developing quantum computers. You'll notice, though, that so far all of these impacts, they're all well, they're all very important. Uh, Nothing I said about quantum computers should lead you to believe that they're going to make a better word processor or they're going to make a better internet. Um, and so, really, the takeaway message that I want to convey with quantum computers is that they're not going to replace your laptop. And when you read in the news anything that kind of extends the scope of capabilities of quantum computers beyond these special types of problems, that article is probably feeding into the hype. Um, and great. So I've talked a little bit about what quantum computers are and what they can do. Um, so now I want to talk a little bit about why it's hard to talk about quantum, especially in popular science. Um, when you read articles, for example, in the New York Times about quantum computers, or you perhaps listen to scientists talk about it, quantum computing often gets lumped in with artificial intelligence. And as we'll talk about later in this talk, AI has a lot of um, has a sort of obvious transformative impact. And when quantum gets lumped in with AI, there's a halo effect that occurs where it's easy to think that if AI is going to change the world in certain ways, then quantum, which sounds better than our normal computing, then quantum must change the world in the same ways. Quantum computing also is a tricky topic to talk about because fundamentally, what's different about quantum computing than, say, what's powering your laptop is a difference in physics. And that physics can be challenging to understand. Even experts in the field will admit that no one truly understands quantum mechanics. And because that underlying physics is challenging, it's counterintuitive, and it's mysterious, it's really easy to sweep BS under the rug when you're talking about quantum computing. Um, and what that means is that quantum is often depicted as more transformative and closer to real world impact than it actually is. As a matter of fact, there are actually a lot of technical challenges that stand between what we can do with quantum computers right now and their ability to solve those special problems that I talked about on the last slide. Those problems most people in the field think are engineering problems that will eventually be solved, but quantum is not something that we're thinking of as being transformative in the next year. Maybe it's 10 or 15 years down the road instead. On the other hand, artificial intelligence is a technology that is really having an impact on the world right now. So just to level set a little bit, because artificial intelligence can have different definitions for different people. For the rest of this talk, I'm going to focus on large language models. So large language models are a specific kind of artificial intelligence that powers ChatGPT or Claude, if you're familiar with those programs. It's these large language models that really, in the last 5 years or so, have gotten people really excited about the ability of artificial intelligence being able to help everyday people with their work, accelerate workflows, change education, etc. So for the rest of this talk, the working model that you should have in your head for AI is something like ChatGPT. Um, so we talked a little bit about quantum's potential impact and how it's narrower than is often discussed about. Personally, I view AI as a more transformative technology for three real reasons. The first is that these large language models, ChatGPT, have seen rapid adoption among the general public. I think that unless you're really keeping track and paying attention to how the technology is moving, it's hard to understand just how quickly people have adopted ChatGPT. So since ChatGPT went public in 2023, it's gone from being used by about 1% of the American public every week to having about a 50% adoption rate. If you think about the, say, adoption rate of electricity, that took about 80 years to get to that point. So we've really compressed this sort of massive adoption in a very short timeline. And there are a bunch of reasons for that. But one of the primary reasons is that people see real value in this technology. Another driving factor behind the rapid adoption is that the capabilities of these large language models are rapidly improving. And that I think is something that is, again, hard to really recognize unless you take a step back and look at the technology. So what I've tried to do here in these two images on the right is show what the output of a large language model to the same prompt was in 2019 versus in 2026. So we're looking at a 7-year difference here. And there's a enormous difference in sort of the complexity and quality of the response to in this case a prompt of the future of AI. So these large language models, they complete text, and back in 2019, if you just typed in the future of AI into one of these large language models, it gave you a little short snippet that might read like a news article, but if you dug into it, it was a bit nonsensical. Whereas today, I asked GPT 5.2, so that's the latest model out of OpenAI. I gave it the same prompt, and its response was complex, detailed, multifaceted. I cut off a lot of the response here, but it really is a sharp description of where AI might be headed in the future. And this rapid advancement has led a number of sort of credible experts in the field to believe that this form of artificial intelligence, these large language models, could have the potential for super intelligence. And what that means is that there's this potential for these large language models to mimic a lot of human capabilities, but at performance levels that exceed humans. The canonical example is thinking about what would the world look like if you had a data center full of Albert Einsteins. And when you put it in that terms, the potential for this technology is really, really revolutionary. Um, but there are a lot of lingering questions, though, about whether that future is actually going to come to pass, which makes forecasting so forecasting the impact and timeline of AI development is really hard. On the last slide, I showed you how in a ChatGPT's ability to respond to prompts has really improved. Unfortunately, those capabilities that capability improvement isn't universal. People in the field like to say that AI capabilities are spiky, in that large language models can be really, 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 really good at some tasks and just fail in pretty mind-numbingly dumb ways on other tasks. And the example that is going around right now is what happens when you ask a large language model whether or not you should drive or walk 20 meters to a car wash when your car needs washed. A lot of these language models will tell you that you should walk to the car wash because you're only 20 meters away, completely ignoring that you need to take your car to the car wash if it's going to get washed. Um, Outside of these kind of baffling failure modes, AI introduces a lot of new security vulnerabilities that are challenging for customers as well as everyday people to deal with. There's a reason why companies didn't immediately shift over to the internet, why kind of the digital transition took some time, and a large part of that was companies, corporations, and the government trying to set up cybersecurity standards. That needs to be done with artificial intelligence as well. We lack some of the infrastructure that we need to do that. But also, maybe even more importantly, the potential for the potential transformative nature of AI has led to kind of a backlash against the technology. When when you mention that uh, these large language models may allow us to build a data center full of Einsteins. From one perspective, that looks awesome. Think of the science that you could do if you had 100,000 Einsteins working for you. But from another perspective, that's actually quite scary. If you have 100,000 Einsteins, then what's the point of employing researchers, say, within the national lab conflict complex or researchers within a company. And I think in the interest of and that idea may sound fantastical, um, but it is a world that in many ways we're approaching. So AI, I think, is really different from quantum in that quantum accelerates certain aspects of science, whereas AI does human work increasingly without the human. Right now, there are versions of Facebook for chatbots where they just go off and do their own thing autonomously, and AI is able to code at sort of near the levels of sort of advanced software engineers. And so even if AI doesn't necessarily advance to that super intelligence level, AI is right now and is going to continue to impact the workforce, which leads to a lot of anxiety around AI, and again, some of that backlash to AI. So I think to conclude, because I think this will put me at about the 20-minute mark. Um, I think in summary, what I hope y'all take away from this talk is that quantum computing and artificial intelligence, although they're both emerging technologies with the potential to really be game changing, they're game changing in different ways. So quantum computing is going to have a meaningful yet limited impact that you're not really going to see in your day-to-day life, except insofar as it accelerates scientific research or maybe leads to some shifts in corporate and government policies on cybersecurity. Quantum computing is also still in the early stages of making an impact, and so it's really important to not get caught in the hype cycle because it's a little riskier than, say, artificial intelligence, which really is making an impact today, despite the fact that there are some real technological hurdles to it achieving its potential. But because it has this enormous potential, there's really genuine and valid anxiety around how artificial intelligence is going to shape the world, whether or not it's gonna take jobs, and how people of sort of my generation or people who are in school now navigate our lives for the next 30 years when there's so much uncertainty around what jobs are going to look like in 5 years when artificial intelligence can do a lot of white collar work autonomously. Um, so that's the end of my presentation. I'm going to go ahead and stop sharing, and open up the floor to questions.
First of all, yeah, thanks a lot, Daniel. That was pretty informative. I think you covered there's that was well said in a short amount of time because those are such big topics with layers of underneath. Um, right off the bat, I was kind of curious. You hear about something called artificial general intelligence. I think that's where like the machines could be as smart as humans. I don't know. Um, and you talk, I hear about a horizon where that could be coming. I was curious to get your opinion. When do you think th these machines will like be AGI status?
I forgot to say this when I said what the talk was going to be. I meant to say what the talk is not going to be, and that is it's probably not going to have a lot of concrete answers, and that's because I think it's really, again, really challenging to forecast the future of artificial intelligence.
Okay.
With that being said, there are, you know, very different estimates from different people in the community about when AGI or ASI, which stands for artificial super intelligence, may be achieved. If you listen to people like Dario Amodei, who is the um, one of the founders of Anthropic, or you listen to Sam Altman, they'll tell you that AGI, which, like you said, Norm, is really the ability of artificial intelligence, of some sort of artificial intelligence agent to act autonomously and carry out um, a large number of tasks that typically require human intelligence at the level of a human. They'll tell you that AGI is right around the corner, that
Yeah.
it's 2, 3 years down the road max. Now, a number of their predictions have sort of been pushed off. But if you look at credible forecasters, you're probably looking at a range of 5 to 10 years if if the current rate of progress continues. And we really haven't seen much of a slowdown in that rate of progress. With that being said, that doesn't mean that you won't hit a wrench in the road. There are some AI doubters who think that the current technology can never sort of really replicate human performance because of some of the limitations. And so they'll tell you that it's not never going to come. Mm.
Mm.
But even if you don't achieve AGI, like AI, I think there are two things that are holding AI's sort of enormous potential. The first is AI capabilities. So if we can get to AGI, that's obviously transformative. But the second thing that's holding AI back is really a lack of infrastructure and an understanding for how to integrate artificial intelligence into the workplace right now. And so there's a lot of actual sort of capabilities and a lot of things that AI could do if we were putting it to better use because we had better infrastructure. So even if AI weren't to advance at all today, we never get AGI, it's going to be pretty disruptive on the workforce once we figure out how to correctly integrate it. And that's even true for me. ChatGPT is writing journal level physics papers right now. I'm a physicist, so even if ChatGPT doesn't get any better, there's a lot of room for it to help me do my job, but also, maybe replace me. So long-winded answer. I apologize.
I think that's great. Thank you. It's like you said, it's you're just trying to predict the future here.
Yeah.
I think Christine, did you have a question?
Yeah, I wondered, Daniel, to your point about ChatGPT writing physics papers, what's the role of like the innovation historically has been where humans have added value, right?
Mhm.
So yes, ChatGPT can write a summary of existing literature and recap that, but what about the innovation piece? How does all of that play into it in this context?
So I'll dodge the question a little bit with, I think, one of my most, and I apologize if this sounds needlessly pessimistic, but if you think about when I think about the majority of sort of human work, whether that's scientific output or white collar jobs. Um, a lot of that does not require innovation, right? I mean, I'm not as pessimistic as Daniel Graeber and his sort of bullshit jobs view on the world, but a lot of what we do is fairly straightforward. It's incremental progress, and a lot of it relies on pattern matching. And AI is really, really, really good at pattern matching. That's kind of how it got the result that it got when it recently published a paper. It looked at some patterns, simplified what was happening, and then extended the result. So even for science, the majority of scientific output is not incredibly creative. Um, and so I think there's no reason to expect AI can't do that and push science forward. There is a risk though, that because AI is really learning to pattern match off of the immense data that it's stored, we may be missing out on, like you said, the truly, truly creative and paradigm shifting ideas that have historically really driven humankind forward. Um, Interestingly, artificial intelligence, right, is one of those ideas. Something like quantum mechanics, which underpins quantum computers, is another one of those ideas. Those required radical shifts in perspectives about how we think about the world, and it's an open question as to whether or not you can get there by just when the systems that you're building are really, really focused um, on predicting what's gonna come next from the information that it has. Um, but so I think that's maybe a pessimistic answer, which is that um, I actually think innovation and sort of human creativity is a lot less important in a lot of what we do. Um, and it's an open question as to whether that's sort of like the cases where it matters will will be sort of inaccessible to artificial intelligence. Yeah. And Chris, I think you have your hand out.
Yeah, thank you for the presentation. Very, very interesting. I had a question about energy use. There's a lot of talk
Yeah.
about how AI and the things that go with it, I guess, are demanding a lot of energy, and it was going to, require us to build a whole bunch of new generation, and drive up or drive up electricity prices in the areas where the facilities are built. Is there a reason why that's inherently true? Could the processes get more efficient? Like there was, I think, a blip, maybe a year ago about a Chinese version of some of this AI that was, like 1/10 of the electricity use. Is there a way to cut that down, or is it inherent to what we do?
Um, so the nerdy rabbit hole answer is there is a fundamental limitation somewhere on the efficiency. We're nowhere near that though. So the real answer to your question is yes. As the technology advances, people will whenever there are constraints, people tend to optimize and try to make themselves more efficient on those constraints. It reduces costs, right? And so there are different ways to build and query these models so that they're more energy efficient. That's actually what unlocked this latest revolution. ChatGPT doesn't happen if not for someone in 2017 realizing that they could make the model architecture that everyone was using a lot more efficient to train. It required a lot less time, a lot less energy, a lot less compute. And that meant that you could build bigger and bigger models that were a lot more performant. Um, so the answer is yes, people can get more efficient. Um, then again, though, right? What do I want to say here? Value sort of creates demand, right? So even if you make these models more efficient, the more capable they become, the more autonomous they become, you could still see sort of energy demands outstripping the efficiency gains. And that's I'm a scientist. I have an interest in science policy and in domestic policy, but my primary role is I like to think about informing those conversations, and so I'll sort of do the ultimate pass the buck and say that in terms of making those decisions about, right, where do you put facilities, what's the right allocation of sort of energy, that's for the policymakers and elected officials who are accountable to, right, to the people that they represent and the places where those facilities go in. So yeah. And real quick, because sorry, I gotta go, but that does get to, something I didn't talk about is AI can be great, but it will probably exacerbate a number of sort of inequities that exist in society, whether that's with placement of data centers or sort of continuing to proliferate sort of biases that exist on the internet and whatnot. So there's a lot of other challenges that come with AI and questions around what we should do with it. And yeah.
Thank you.
Yeah, Daniel, thank you so much for being here. I know you got to run. If you have any extra time, let us know. But otherwise, thank you for this informative talk.
Yeah, I can probably maybe take one more question.
I was curious. You hear about quantum computing changing encryption and the way we secure networks and things like that. How long before quantum can break through all the password protection and kind of the current way of securing things?
I don't think anyone has a specific date for that. Um, but the I mean the federal government sort of views quantum computing as a credible threat to encryption. And so they are right now in the process of creating standards for what's called post-quantum encryption. So migrating over the encryption protocols that we use to algorithms that are believed to be hard to decrypt for both classical computers and quantum computers. So I don't think there's a specific date, but the federal government believes it's a credible threat and is really trying to get people to migrate to security that works, even in a world where quantum you have sort of impactful quantum computers.
Perfect. Thank you.
Yeah. All right. So yeah, thanks all. Thanks for having me.
Thank you
I hope
so much.
it was informative and enjoyable. So have a
Yeah, we
great
look
day.
forward to hosting you in person next time you're in town.
Yeah.
Thank you. What a smart young man.
All right.
Wow.
Thanks.
Definitely. It's like one of those talks where you realize how much you don't know.
Exactly. I felt that too, Chris.
Sometimes I'm glad to be old and close to retirement.
Yeah, yeah.
Just think about sitting around the dinner table with Daniel when you get him going. It can take 45 minutes to answer one small question.
I do
I
think you
didn't
did a
even
great
I didn't
job,
even
Lisa, in making the presentation understandable to people who, like me, don't understand any of this stuff. So I thought he did a great job, and I won't say dumbing it down, but making it more understandable.
Yeah, good job to Lisa for raising a smart son.
Yeah, really.
He's an alien. He's not. He doesn't- But
He did a
really,
great job.
yesterday he sent me a picture of an outfit and he said, "Is this business casual? I'm packing to get on a trip to go to Boston in a little while." And I'm like, "Daniel, you gonna still do your talk tomorrow?" He's like, "Oh yeah, I'm gonna work on my presentation on the plane." So
He did a great job.
I was nervous, so I'm glad it worked out.
I agree. Great job. That's a big topic.
Yeah. It's a
Probably
lot
could
of
have him
work to
back.
take something complex and make it understandable to a lay audience. So you did a great job at that.
For sure. Well, I see we're wrapping up. I think we have enough time to enter and to induct Jen. That sounds like fun. Okay, cool. Jen, remind me how you say your last name.
It's Daniso.
Daniso. Perfect.
Yes. Yes.
Gotcha. All right, let's do it.
Oh,
Let's
I really hope my dog is not going to bark. Okay.
Well, that just means good luck.
All right.
Yeah, it just means good luck. So, fellow Rotarians, it's my privilege and pleasure today to welcome our new member, Jen Daniso, into the Rotary Club of Arlington and the friendship of Rotary throughout the world. Jen, the club board of directors has reviewed your application in accordance with our constitution, bylaws, is pleased to approve your membership. In doing so, we believe you'll promote the ideals of Rotary as follows. All Rotarians are expected to exemplify the principles of Rotary in their professional and personal lives and to practice goodwill, service in the local community. Our motto is service above self, and the purpose of the club and Rotary clubs is to encourage and foster this ideal. Rotarians are people of action, and each club member is expected to perform his or her share of club and community service and to willingly participate in the activities of leadership, roles, and committees in the club. Rotarians also share an ideal of fellowship and friendship, as you would hope to receive and give. May the fellowship of the members encourage you, and may we in return know you to be an added source of strength to our club. Jen, the principles and Jen, the principles and obligations of Rotary have been summarized for you, and you've expressed your willingness to become a Rotarian. Do you agree to accept the privileges and obligations of membership in the club, to provide leadership when asked, and to willingly participate in the endeavors of the club?
Yes, I do. Absolutely.
Fantastic. Welcome to the Rotary Club of
Great.
Arlington.
Thank you. Thank you very much.
The world's newest Rotarian is right here with us in this moment. We're super,
Thank you.
so glad to have you.
Thank you.
Absolutely. Absolutely. Well, as we wrap up, I want to remind folks, that I think it's next week. We've got the first Tuesday happy hour over at Barley Mac. And then if anyone's still just to keep it on your calendar, the Joe Lott Celebration of Life is still upcoming March 14th. So that's something out there. But I hope to see you guys all next week at the club happy hour. All right.
Right.
Fantastic.
See you next week. Thank you,
Great.
everyone.
Thank you.
Bye.
Thank you.
All right.
What?